Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Soffian bin Abdul Rahman. My supervisor is Dr. Justin binti Jelani and my co-supervisor is Sir Wan Muhammad Shafwan bin Muhammad Sabri. This research is about geotechnical investigation of landslide incident at Kemensah in 2021. On 18 September 2021, Malaysia has been shocked by news of landslide incident that happened at Kemensah, Kuala Lumpur. The objective of this study is to determine soil properties, site characteristics, geological and hydrological condition of the landslide site at Kemensah, and to evaluate the stability of Kemensah slope using finite element software, Platsys 3D, and validate the result with field survey. Third is to determine landslide causal factors for Kemensah slope. This is my study area. Kemensah is located in Ampang Jaya province, which is 13 km from Kuala Lumpur city centre. The bedrock of Ampang is mainly composed of granite rock. The landslide cover approximately 2,536 meters squared with length and height is 18 meter and 45 meter. This is my methodology in this investigation. For this study, there are 4 sources of the data we can get. First, from the local news. Second, geological map from the GMG, rainfall data from GPS. That is from Google Earth. For site reconnaissance, TLS is used to obtain the dimension of the landslide at the site. From soil sampling, we can collect the disturbed sample and the undisturbed sample to do the laboratory test. In field testing, I do JKR probe test. There are 8 laboratory tests. First, triaxial test, permeability, sieve analysis, soil compaction, shear box, athabag limit, moisture content, and lastly, particle density. For objective 2, numerical simulation using Platsys 3D was used to get the factor of safety at the slope. For objective 3, I will determine the landslide causal factor based on what have been analysis result. First, JKR probe test result. From JKR probe test, the hard layer located at depth 3.5 meter to 6 meter from the failure plane. Second, laboratory test. For particle size distribution, the soil is classified as silty sand based on British Standard Soil Classification. Figure A show the result of particle density, while Figure B show the result of permeability. From the permeability, we can get the coefficient permeability. Figure C show the result of athabag limit, and from that, we can know that the soil is low plasticity. Figure D state that the optimum moisture content is 7.3% with maximum dry density is 16.51 kg meter cube. And from figure E, the shear strength parameter we get from the shear box. Same goes to the figure F, the triaxial test, to get the second stiffness to input in Platsys 3D. Figure G show the deviatoric stress strain curve obtained for the 3 confining pressure. Then we can get the data of E50 from the graph gradient for each specimen. After that, the total average value of E50, we can get the E50 reference. Table H show the EOD reference and EUR reference that we get from the manual calculation based on previous research. To get the EOD reference, it is equal to the E50 reference divided by 1.25. And for EUR reference is equal to E50 reference multiplied by 3. Lastly, for figure I, we summarize the input strength parameters. Third, comparison between Platsys 3D and slope over W. Figure A shows the critical slip plane occurred at the crest and intersect at the toe of slope. The failure line is categorized as toe failure. The factor of safety we get from Platsys 3D is 1.995, which is considered stable. We also do at software slope over W, and the factor of safety is 1.658. This difference, FOS, are due to difference in method of analysis of the two software, which is slope over W, analyze slope stability based on static equilibrium, while Plexis 3D is based on stress-strain relationship. Figure C show that the type of failure observed at the site is similar to the Plexis and slope over W. In conclusion, there are four main factors that trigger the landslide. First, antecedent rainfall. Second, excessive surcharge load constructed at the edge of the slope. Third, the type of soil consists of low strength cohesion and low plasticity. The soil also classified as medium permeability indicate that water can penetrate into soil during rainfall. Four, the existence of two distinguished hard and soft layer is determined through JKR prop test. That's all from me. Thank you.